now. There are also some counterexamples, interesting places where economies have collapsed without social collapse, and they do have some quite interesting lessons to show how that occurs, how you defend social resilience in the face of an economic collapse is a really interesting question. But that, fundamentally, is the dilemma of growth. Growth is unsustainable, degrowth is unstable, and so we know both of these things. We've known them for decades. The question that leaps to the mind is, what is the official response to this, particularly in those nations who have accepted broadly that we need to do something about climate change, that we are living unsustainably, that our resource base is fragile. So what is the solution? And the main solution is the idea of decoupling. It's the idea that it's possible, in fact, to keep growth, to keep economic growth, to keep that thing that we know is important for stability, and yet for it to become lighter and lighter and lighter in material terms, to take the materials out of growth, to remove its dependency on polluting resources, to remove its dependency on carbon, to get it to a state where we can increase economic activity. It's an interesting question what those economic activities are. I'll come back to that. And yet to remove our damaging dependency on material resources and environmental emissions. So it's really important to say decoupling, what's the reality of that? And a lot of the report is about exploring that reality. Some of the report, statistics in the report are about exploring that reality. And I call this, the chapter in the report is called The Myth of Decoupling. And it's really important to notice that the myth of decoupling, the decoupling itself is incredibly important. It's clear that even at the scale that we have at the moment, it's absolutely vital to reduce the material dependency of the economy in that context. But what I'm referring to here, so decoupling itself very important. What I'm referring to here as the myth of decoupling is an idea that really has emerged through the technological optimism of the 1990s and concepts of ecological modernization, that actually our economies are going in that direction already. In fact, because they're capitalist economies, because we prize efficiency, our profit motive itself will mean that we do things with fewer and fewer resources, and all kinds of examples are cited of industries that have become more efficient in relation to their material input costs. And indeed, there's some evidence, and I'm going to look at the evidence in a minute, to suggest that some nations also, because they are advanced technological nations, have somehow managed to free themselves and already decoupled from the material impacts. Now, that, if it's true, is a really important argument. It's in favour of a technological optimism, but we do have to be absolutely clear that we agree the robustness of that evidence. And some of the evidence, I'll show you a couple of graphs in a minute, but it's also very important to distinguish between two different concepts of decoupling. One is relative decoupling, and the other is absolute decoupling. This is a little bit technical, but I just want to draw your attention. It's fairly straightforward to understand, and if you think about the intensity, resource intensity of a dollar of economic activity. So let's say we're going to look at the carbon intensity of a dollar of economic activity. So relative decoupling happens when the carbon intensity of each dollar of economic activity goes down and down and down. We're getting more efficient, essentially. And you look at the evidence and you say, yes, actually, globally, we have become around about 30% more efficient in carbon terms per dollar of economic activity than we were a couple of decades ago. That's great. That's fantastic. But what's happened to absolute carbon emissions? What is the level of absolute throughput? And in the same time, actually since 1990, carbon dioxide emissions globally have increased by 40%. So what's going on here? We're getting more efficient here, but actually carbon emissions have increased. And there are two things going on. One is the obvious balance between efficiency on the one hand and scale on the other. We're getting more efficient in terms of the intensity per dollar, but we're increasing the number of dollars of throughput, and the dollars outweigh the technological efficiency. Scale outweighs efficiency in almost all of the examples that you look at. And the second thing that's going on, which is a very interesting sort of phenomenon, is that you can't actually identify clearly that we have decoupled. Because one of the things that happens when you do things more efficiently is that you allow more activity, and more activity scales the impacts up even as efficiency pulls them down again. So that balance between efficiency and scale continues actually to haunt us and to lead to a situation in which ultimately we have failed to make progress against the Kyoto targets at the global level. So let me just show you a little bit of that failure. I mean, it's a very key lesson that the evidence of absolute decoupling, and you can look at it in carbon, you can look at it in resources, you can look at it in land, you can look at it in lots of places, is virtually absent. Okay, we didn't do so well, perhaps we could do better in the future, yes, of course. But, and here's another hard lesson, that the prospects for decoupling fast enough are ambitious at best. Here's a little bit of data. Here's all you need to see about these graphs, really, is that they go up. They're graphs of fossil fuel consumption against the world GDP. The top line is the world GDP. So you can see, because fossil fuel consumption lies below the line, that essentially means that we do see some relative decoupling. Although, if you look at, I'm not sure if you can see this little red light, you probably can't, but if you look at coal, for example, there in the later decade, it's increasing faster than GDP. In other words, we're becoming less efficient in global terms than we were before. So nothing very much there in the way of comfort that we've achieved, actually even relative decoupling. And here's another set of evidence. This is the extraction of metallic resources, and there you see the world GDP line is right clustered in the middle, and several of those lines are increasing quite a lot faster than GDP. So again, in resource productivity terms, we're going in the wrong direction. Okay, so we didn't do so well. Could we do better? How far do we have to go? And I'll just show this, again, as a simple visual image of the difference and the difficulty of the task ahead. And really all I want you to look at in this graph is the difference between the left-hand side and the right-hand side. And I'll explain what that difference is. Basically, this is where we are now. It's the carbon dioxide intensity per dollar of economic activity in 2007. 768 grams of carbon dioxide per dollar of economic activity. Ingrained in my mind from evenings on the spreadsheet through the production of Prosperity Without Growth. And where we need to be, if we really wanted an equal world, if we wanted a world in which 9 billion people could aspire to the income of the EU countries at the moment, with an added 2% growth along the way, is right down there on the far end at 6 grams of carbon per dollar of economic activity if we want a chance of getting under the IPCC targets for climate stabilisation. That's the scope of the task. And that's only 2050. So here is an economy that's going to grow another 3 times, possibly more, between 2050 and the end of the century. So by the end of the century, actually, well, under some scenarios, a hopeful scenario, you have to get down to 2 grams of carbon dioxide per dollar of economic activity. Under other scenarios, where we actually might need to be engaging in a faster stabilisation, you need an economy that's taking carbon out of the atmosphere. Now, that's a very interesting concept. It's certainly nothing like any kind of economy that we have ever seen. What is an economy that takes carbon out of the atmosphere? What does it run on? What's its resources? What's its fuels? How does it motor? How does it organize itself? How does it govern itself? All of these questions are really so profoundly difficult to answer under the existing model that people tend not to try and answer them. But they are, in fact, the logical consequence of a chain of reasoning that suggests that we can go on growing the economy and remain within ecological limits.